Now let's look at the number 3. If the y equal to cosine of x is shifted pi over 2 to the right, reflected in the x-axis, and shifted 3 units upward, then what is equation of the curve in its final position? So first, we shift this y equal to cosine x to the right by pi over 2, then we get y equal to cosine of the x minus pi over 2. Then you reflect this graph in the x-axis, then you get y equal to negative cosine of x minus pi over 2. And then you shift this graph 3 units upward, so finally you get y equal to negative cosine of the x minus pi over 2 plus 3. So this is equation of the curve in its final position. Now let's look at the number 4. What is the range of this function? To find the range of this function, first we find the minimum of this function. So the minimum of f is achieved when sine of the x matrix has its maximum. We know the maximum of the sine of x matrix is positive 1. So the minimum of this function f is equal to negative 4 times 1 and plus 2, which is equal to negative 2. And when sine of x matrix achieves its maximum, then this f got its when the sine of the x matrix achieves its minimum, then this function f achieves its maximum. So the maximum of f is equal to negative 4, and the minimum of the sine of x matrix is equal to negative 1. So the maximum of this function f is equal to 4 plus 2, 6. Then we get the range of this function. That is the closed interval from negative 2 to 6. Now let's look at the number 5. What is the frequency of the sine wave determined by y equal to sine of the 500 pi times x, where the x is time in minutes? So first, when we get the period of this function, p is equal to 2 pi over the coefficient of x. So there is a 500 pi, and then you get 1 over 250. Then the frequency f, which is the reciprocal of 1 over p, so this is equal to 1 over 250, and then you get 250. So that is a 250 per minute. Now let's look at the section 5.4. It's page 474. Let's first look at the problem 45. And we need to find the exact value of this expression for the given value of theta. And don't use a calculator. So theta is equal to pi over 6. And we need to find the secant square of 2 theta. So 45, we have 2 theta equal to 2 pi over 6. So there is a pi over 3. So secant square of 2 theta is equal to secant square of pi over 3, and this is equal to 1 over cosine square of pi over 3, and we know cosine of pi over 3 is equal to 1/2, so this is 1 over square of 1/2, and this is equal to 1 over 1 over 4. Finally, you get the 4. Now let's look at the 49. 49 theta is equal to 3 pi over 2, and we need to find the secant of the theta over 2. So first, let's get the theta over 2, which is equal to 3 pi over 4. So secant of the theta over 2 is equal to secant of 3 pi over 4. And we know the reference angle of 3 pi over 4 is pi over 4. And 3 pi over 4 is in the quadrant 2. In the quadrant 2, both the secant and the cosine are negative. So this guy is equal to negative secant of the pi over 4. And this is equal to negative 1 over cosine of pi over 4. And cosine of pi over 4 is equal to root of 2 over 2. So now you multiply both numerator and denominator by 2, and this 2 and this 2 cancel. So you get negative 2 over root of 2. And then you rationalize, then you get negative 2 times root of 2 over 2. Cancel these two 2's, you get negative root of 2. Now let's look at the problem 51. Determine the period of this function and sketch at least one cycle of this graph. So it's page 475, problem 51. We have function y equal to tangent of 3x. First, we know the period of this function is equal to the period of tangent x divided by the coefficient of this x. So the period of tangent x is equal to pi. So the period of this guy is equal to pi over 3. Then one cycle for this function is completed for x, okay, for 3x between the negative half pi and half pi. Now we divide both sides by 3, then we get negative pi over 6 less than x and less than the pi over 6. At x equal to negative pi over 6 and the pi over 6, this graph has the vertical asymptotes. So we first draw these two vertical asymptotes. So here I have the negative pi over 6, and here we have the pi over 6, and we know the shape of the graph of tangent function, so it's like this. And in this way we get the graph of this y equal to tangent of 3x for one cycle.